Welcome back, and in this video I'm going to go through the area between two curves or two functions. I'll briefly go through the theory behind it, what's actually happening when we do this, also the formula, and then I'll have three examples that I'll go through. Here are the three examples, so questions 1, 2 and 3. If you want to pause the video, take a screenshot and work through them yourself, then you can check and see if you get the answers right. But on the right here, I'm briefly giving you an idea about what's going to happen, so what sort of area that we'll be finding. So if there's one particular one that you want to skip to in the chapters, you can. This one here, we can see the curves cross over. So this is an interesting one that could easily come up in an exam question. So there we go. They're the three questions. Let's dive in. Okay, so this basic concept can just be understood by looking at these three graphics here. The area between two functions is really just found by finding the area beneath one of the functions, the one that is like higher up on the y-axis, so I call it y upper, and subtract the area beneath the lower function. Okay, so if you put those two together, so we take the larger area and subtract the smaller one, you will get this area, which is what we're looking for. Often we'll need to know limits. So if it's a definite integral, they'll give you a and b, and that'll be the upper and lower limits of your integral. But that is really what is happening here. Okay, so it doesn't matter whether the function is above or below the x-axis. What matters is if you draw a vertical line down through this diagram, we'll see that this line passes, in this instance, f of x first. So I'm just going to call that yu for y upper. It's because the value of y on here is larger than the value of the y on the lower function. So I call this one y lower, so yu and YL. The reason being is because not all functions are going to be labeled f of x and g of x. So we just got to have a concept, an idea about what to do is if they are labeled something different. But in this instance, yes, it is the definite integral of our limits a to b. So those we can see these vertical lines here, a and b. That's where we want to stop. Of f of x minus g of x. And so this would be our y upper minus our y lower. So often in this video, I will refer to them as upper and lower functions as well. And as I just mentioned, if we have to find the area bound between the functions, then in this diagram here, there would be two enclosures. And we could call this the y upper function, and this is the y lower function. So we would use this formula, but with yu minus yl. But at this point here, we'd need to find the intersection because those would cross over, and therefore we would need to relabel this diagram as yu and yl. So whatever the expression for the function is, we would need to swap those in this expression down here. Okay, question 1. So find the area of the region enclosed by the curves g of x is x plus 2 and h of x is x squared plus x minus 2. Also between minus 1 and 1. Now, if you did this on a calculator, this is what it would look like. And often these graphical calculators can just find the area if you put the upper and lower limit in. But let's assume that you're doing this on a non-calculator. Okay, so we have x plus 2, so that is a straight line. So that's going to be g of x. And it would pass through the axis here at minus 2. I know that because the value that makes this 0 is minus 2. It also pass through the y-axis at 2, so let's just put that on. And also the quadratic here, okay, so let's just do that over in blue down the side here, that is factorizable. So this is h of x, and is factorizable to x plus 2 and x minus 1. Therefore, then I can see then it's going to cross the x-axis either when x is minus 2 or when x is 1. So that's convenient because it passes through minus 2. It also passes through negative 2 here, and it's going to pass through at 1. Right, so this is 1. So putting all that together then, it also says that the limits were minus 1 to 1. So minus 1 to 1, well, that would be, minus 1 will be here, and 1 is already dictated there. So we're going to be finding this area. So let's just shade that. Right, so let's go ahead, and if we putting all of that into an integral, notation here now. The area is found between -1 and 1 of y upper. Now, as I said before, the upper function would be g of x in this case. So that is x plus 2. So it's going to be x plus 2 subtract the lower function. So in this case, this would be the lower function, which would be the quadratic. So that'll be x squared plus x minus 2 with respect to dx. So I'll just write down that this was the upper function, y upper, minus the y lower there. Now, what you can do first is you can tidy this up before you do any integration. So this will be, well, x subtract x is going to disappear. Then we've got 2 minus minus 2. So that will be 4. And these limits will go in. And we have minus x squared. So we've just tidied all of that up before we plugged anything in, which makes it quite a lot easier. Okay, so let's go ahead and integrate. So add 1 to the power, divide by the new power, add 1 to the power, divide by the new power, put your square brackets on, and then put your limits. So this is going to be 1 and minus 1. Go ahead and substitute them in one at a time. So we plug 1 into this and then this. So that would be equal to 4. Subtract 1 over 3, close brackets, minus, now we're going to plug the negative 1 in, so that would be minus 4, and this will be minus times a minus times a minus, then also times a minus, that's actually going to be a plus 1 over 3. So tidying that up is 4, so it'll be 8, and we've got minus 1/3 minus 1/3, so minus 2/3, leaving us with 7 1/3 units squared. And that's the end of the first question. Okay, question 2. So find the area enclosed by the curve y equals 4 minus x and 2 over x minus 1. So if you did this on the calculator, this is what you're going to get. And like I said, a lot of calculators can just calculate the area, but often this comes up on a non-calculator paper. So let's draw the axes and 4 minus x. So that is a straight line, right? So 4 minus x is a negative gradient of minus 1, and it passes through 4. Now, it does say the area was enclosed. Now, you do need a little bit of knowledge of functions here, because this is what we call like a rational function. These functions either have this shape, right? Or they will have this shape. So I sort of say that they're in quadrants 1 and 3, or either in 2 and 4. Now, in this instance here, a very simple way to test that is basically to see what happens when you plug x is 0 into this. So you get 2 over minus 1, which is minus 2. So when x is 0, it will pass through minus 2. Okay, so therefore then, we will get this shape here passing through minus 2, and this shape like here, right? So if you're a bit confused by that, that is a rational functions style problem, and therefore we can now find the enclosure between these two, right? So what we'll need to do is we'll need to equate these two together. So just to be super clear, we are finding the area in between these two functions here. So straight away, I would say that this is the upper function, and the one here is the lower function, right? The sort of the rational function. So let's go ahead and find the intercepts. So when does 4 minus x equal 2 over x minus 1? Well, times both sides by the x minus 1. So we get x minus 4 times by x minus 1 is equal to 2. So we're going to get 4x minus 4 minus x squared plus x, okay, is equal to 2. And we can just solve this quadratic. So minus 3 and minus 2. So therefore then, it intercepts either when x is equal to 3 or x is equal to 2. Right, so these limits here are going to be 2 and 3. Right, those determine the definite integral that we need to do now. So let's go ahead and do that. So we've got the area between these is 2 to 3 of the upper function. Now that was, if you can see from here, that's going to be the linear line, and that was determined by 4 minus x. So 4 minus x subtract the lower function, and that would be that rational function, which is 2 over x minus 1. So 2 over x minus 1 and dx. Now we have to integrate this, so let's go ahead and do that. I'm not going to tidy anything up. It's not so easy to do that. So we're going to say that this becomes 4x. This becomes x squared over 2. And this here is going to become a natural log. So it's negative 2 natural log x minus 1. So watch my video on integrating this style of expression to get natural log. And that is all in square brackets between 3 and 2. So let's go ahead and plug all of that in. So when we plug 3 in, we're going to get 12 minus 9 over 2 minus 2 natural log 2. And that is all subtract. Let's just do this in a different color. Let's plug 2 into this. So we're going to get 8 minus, now 2 squared is 4. 4 divided by 2 is 2. Minus 2 natural log. Now 2 minus 1 is 1, and we've seen this a few times. Let's just close that bracket off for now, but this is going to be 0, right? So this here is all going to be 0 because natural log of 1 is 0. So, and 8 minus 2 is also 6, so let's just tidy this up. We've got 12 minus 6, so that'd be 6 minus 9 over 2 minus 2 natural log 2. And 9 over, well, we can just change this to be over 1. So we get 12 over 2 minus 9 over 2 minus 2 natural log 2. And so that would be 3 over 2 minus 2 natural log 2 as an exact term. And don't forget, it's units squared because it is an area. And that's the end of question 2. Okay, on to question 3. So this involves a quadratic and a linear line, and also then 2 points that we need to move between -2 to 0. So if you did this on a calculator, that's what you'll get, and you'll need to find those 2 areas independently. And also just note that depending on what you're doing, you just need to probably find this intercept here between the 2 functions. So what I'll do is I'll assume that we don't have a calculator, and we are going to do it manually. So let's go. So x squared minus 2 is the concave up quadratic passing through -2. Let's go ahead and just put -2. The intercepts here and here, well, if we let this x squared minus 2 equal to 0, so x squared would equal to 2, so x is equal to plus or minus root 2. So these intercepts are either plus root 2 or minus root 2. Now that's quite important because we want to mark this -2 and 0, which will be like the points that we are trying to find the area between. So that's going to fall outside -2, and 0 is the origin. So let's go ahead now and now do the linear line, which is this one in pink. So f of x is equal to x, so that's this straight line just passing straight through, so y equals x essentially. And that means that we want to find this area, so it's from -2, let's try and get that straight there, so it's all of this area here, and all the way to 0, so it's all of this area here. So we want to set this up sort of quite carefully, right? So area is equal to -2 to this intercept there. Now I actually just need to find that, so okay, so that's going to be x squared minus 2 is equal to x, because what I'm going to do is I'm basically equating these 2 functions together here. I just want to know when they touch. So let's, looks like it's going to be a quadratic and nice and factorizable. So x, what is it? X minus 2, x plus 1. There we go. So we can determine that the functions touch each other or cross each other at x is equal to 2 or x is equal to -1, right? So if we just go over to here, this location here would actually be -1. The other location 2 is not really of relevance because it's going to be here, right? So that's going to be 2, but because it's out of the window that we're looking for, we're not too interested in that. So therefore then that -1 will become my upper limit. And the upper function will be the quadratic, so that's x squared minus 2. Subtract the lower function, in this case would be x, and that's all with respect to dx. Now that's only just part of the problem, because now we have to deal with the other part when the functions cross over. So there are, what I'll do is I'll say I'll sum that to when we're going from -1 to 0, but they've crossed over now. So this is going to be x minus, and it'd be x squared minus 2 dx, right? So always check which is the upper function, which is the lower function. And let's go ahead and do that now. So we've got x cubed over 3 minus 2x minus x squared over 2. And that's all with the limits -1 and -2. And now we have to do the same here. So we're going to have x squared over 2 minus x cubed over 3 plus 2x, right? And with limits 0 and -1. So we're going to substitute in the upper bound. So that's going to be -1 over 3, and that's going to be plus 2. This will become -1 over 2, and that's subtract, and then we'll plug -2 in, so we're going to get -8 over 3, and this will be positive 4, and this will be 2 over 2, so 4 over 2, which would be -2. Okay, now that is just this bracket that I've just done. So we still have the other one to do, but I think I'm just going to tidy this one up first before we do anything. So we've got 2. It's going to be 11 over 6, right? So that first bracket comes out to be 11 over 6. So, now we need to sum this to this expression over here, which I'm just drawing a cloud round. Right, so we've got to do this all over again. So I'm going to open large brackets, but don't forget we're going to have to substitute 0 in first. So it will be 0 minus 0 plus 0, so that's all 0. Subtract, plug -1 in. So that's going to be close larger brackets because you're subtracting. Remember, you're sort of doing this whole expression here independently, and then that in the brackets then will be plus open, so it'll be 0, and we have, and that's going to come out to be over 6, so 9 minus 2, so that's 7 over 6, right? So that whole second bracket comes out to be 7 over 6. So putting all this together, we got this 11 over 6 plus 7 over 6, which is 18 over 6, which is 3 units squared. Done. Let me know how you get on in the comments below. Don't forget to like and subscribe to the channel. See you next time.